Focus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and this is Gary Kildall. On today's program, we're going to be talking about integrated software, the new breed of business programs which all work together. And when we mention integrated software, you probably think of Apple's Lisa. Well, in just a few minutes, we're going to be talking to the man behind the Lisa project, John Couch. But first, Gary, there really was integrated software before Lisa, wasn't there?
Well, we're actually talking about two different interrelated topics. One of them is integrated applications, and the other is the use of a visual interface. Integrated applications generally is a term that's applied to business applications that work together, such as a word processing system, a spreadsheet, a graphics drawing package. And they're integrated when they use common data formats and common command formats. The second topic is really the visual interface. The visual interface really uses a new technology of high-resolution graphics to make that program-to-user interface a little more enhanced and animated and a little more fun to deal with. So the Lisa and also the Vision that we'll be seeing today are really descendants of the Xerox Star, which was really then in turn a descendant of the work that was done by Alan Kay and Smalltalk at Xerox PARC.
Okay, before we meet John Couch and Lisa, let's take a background look at the principle of integrating work functions.
Integrating the various branches of an organization to work in unison has never been simple. If each task or department is isolated, making them work together requires clear and accessible channels of communication. At the very least, they all need a common language to clearly assign jobs, coordinate tasks, and make changes as quickly and as directly as possible. In this regard, computer software has a long way to go. Until very recently, the kind of software programs available to businesses, for example, performed single, separated functions, like word processing or graphics. With integrated software, several functions can be combined into one package, available at the same terminal, using the same language. A common database allows an operator to perform several tasks simultaneously and to switch quickly from one task to another by splitting up the screen or creating windows that overlap. Integrated software has its routine commercial applications, business records, office management, spreadsheets, the corporate bureaucracy. But the concept of integrating programs and program directions is part of a long-range goal critical to the development of more manageable computers, making the machine easier to use. Integrated software is a step in that direction, using a low level of artificial intelligence to manipulate diverse programs like tools. Paradoxically, the simpler a program is for the user, the more complex it must be for the machine. And to some experts, today's small computers are still too immature to use integrated software effectively.
Joining us now is John Couch, the creator of Lisa, formerly with Apple, and now off doing quite a few things on his own. Welcome to Computer Chronicles, John. Gary?
Well, John, I mentioned earlier in the opening segment that the Lisa machine seems to be related to Smalltalk and the Xerox Star. I remember it's been over 10 years ago I went to Xerox PARC and saw a high-resolution display like this. Can you give us some idea what that genealogy is? How did we end up with a Lisa?
Well, it really goes back to 1978 when I joined Apple Computer and went to work with Steve Jobs in a group called New Products. Our job was very simply to define the new products or the personal computer of the 1980s. And we attempted at that particular time to address some of the concerns that we had in terms of the growth of the personal computer industry via the Apple II. One of them certainly was that we felt the machines were too difficult to use. It required a person to learn a new language, a command language, in order to use the machine, and there was very little integration amongst the applications. It was very difficult to take data from one application into another application, and those systems that were integrated what I call at the file level, where you could write information to a file and read that file into another application, but then again you were forced to go through the command interpreter, through the command language, to learn how to use that system. We saw the Xerox work, a lot of us during grad school, like yourself, and came to the conclusion that we could build a personal computer, taking advantage of the new technology in terms of the bitmap display, replace the command interpreter entirely with a graphics language. In other words, emulating the way people work in an office rather than asking them to change the way they do things, and use that same user interface to provide the integration in terms of moving data from one application to another.
Now, the real breakthrough here was in the price, wasn't it? The Xerox Star is a very expensive machine, and the Lisa is relatively inexpensive, but it still is criticized for being high-priced.
Right. It's really interesting because if you look at the Star, yes, it was high-priced, and I think the real benefit of the Star was the alternate user interface, the displacing of the command interpreter. There was really very little integration as we define integration in terms of moving data from one application to another on the original Star. There was no spreadsheet. There was fundamentally integration between graphics and text, and that's where the integration stopped. Our goal was to build a software architecture such that, and what I mean by architecture is it's like a home. It's what the house looks like to the outside person. Is it a French country or is it English Tudor? And how it's built in terms of the data structure. Our goal was to define a software architecture that would define the path for data movement and at the same time using a graphics user interface such that integration was a very cornerstone of that architecture. In other words, you could take data not only from word processing, business graphics, but from spreadsheets as well as accounting packages and any other piece of software that were to be written on the Lisa system. You would be able to cut and paste that data.
John, what kind of user did you have in mind when you designed something like Lisa?
To tell you the truth, we had ourselves in mind. One of the things about Apple Computer is there's this desire to build products that we ourselves wanted. And, originally Steve Jobs and Steve Wozniak wanted a personal computer. They couldn't afford to go out and buy one, so they built one themselves, a la the Apple II. In looking at the Xerox Star, we wanted a computer that was integrated, that was easier to use. We set a goal for a learning time of less than a half hour. We felt that was the limitation in terms of really penetrating the personal computer marketplace, that although we've sold over a million Apple IIs, that there are still 32.5 million people out there in the office today that could benefit from a tool like a personal computer. And the single limiting factor was they were difficult to use. We asked them to learn something new. They didn't have the time to do that, and they couldn't integrate the typical functions that they did in their daily job. So our first goal was to build a product that we ourselves wanted. If you remember, I think Apple did away with typewriters back in 1979 and sort of built our company on top of personal computer technology. We grew from 7 million to 1 billion with at least one personal computer on everybody's desk and at least one at home, and in some cases 2 or 3 in an environment.
I want to go back just for a minute to, you mentioned there was a half-hour learning time for the Lisa. It's also been criticized that half-hour learning time is done through all the graphics. That is kind of cutesy-oriented, the lid that opens up in the trash can and things like that, and that this tends to get tiresome. Is that tiresome and actually get in the way when someone learns the Lisa well? Is that criticism really true, or?
I don't see that, and I haven't seen that. I think that some of the things that I've seen. I've used the system myself since I've been outside of Apple since June. I've put a complete financial plan, which now stands about 2 inches thick, and so I've used the system myself extensively, and I've definitely learned a lot about where I would like to see integrated software go, and where I think the software industry in general is going, and the limitations of the Lisa architecture. But I don't see that at all. I think that the garbage can was just something that we chose as an alternative to saying delete your files. You simply pick up a document and throw it into the garbage can. Everyone knows how to throw paper away.
Does integration of software, as you put it together in Lisa, depend on any technological breakthrough? Did you have to solve any particular problem to get to this level of integration?
I think so. I think if you look at software, at least my view of software had been, in particular like programming languages, you tended to deal with arithmetic operators, add, subtract, multiply, and divide, and the data types tended to be very fixed. Integer numbers are real numbers, and therefore you did add, subtract on 2 integer numbers. There's a very well-defined calculus for the result of adding 2 integer numbers together or multiplying 2 integer numbers. When we took a look at the data structures for the Lisa system, they weren't simply just numeric numbers or floating point numbers. They tended to be textual strings, say the things you deal with word processing, data structures that represented high-resolution graphics, data structures that potentially could represent voice. So they were very unique data structures. And the operations on those data structures, which would be tree structures or linked lists, something of this nature, were not just add, subtract, and multiply. They were very complex mapping function in order to map a data structure that represents, say, a pie chart into a word processor that didn't understand pie charts at all. And
John, we only have a couple of minutes, unfortunately, to demonstrate this, so I kind of want to rush you along into it. Maybe you can show us with the Lisa here an example of how you'd move from one software program to another.
What I have on the screen is a number of windows, and I think that's certainly one of becoming the buzzwords of 1983, integration and Windows. But we have the mouse and we have the what we call pull-down menus, and these are the traditional menus, except we don't take the real estate on the screen. And then we have a number of windows, in this particular case, applications, and you can have as many on the screen as you'd like. We basically point to something, select it. You can tell the selected object because it's blackened here, and if I wanted to move to some other place on the screen, it would simply be a matter of pointing to that, pushing the button, and control is now transferred from that particular application to this application, so I can go back. And I can move these windows around on the screen like I can move any of the objects on the screen. I can size them to be any particular size or shape. I can scroll with them in them and do whatever. This particular application that I happen to bring with me, I own a computer store called Computer Kingdom. It happens to be the sales for 1982, and I can enlarge this a little bit, and you can see that I have sales, the month, the hardware sales, software sales, and some training sales. And the object was simply to point to the data. Our goal was to point to things, and so I simply point to the data, like for the sales from January through December for both hardware and software. I go up to the verbs. We consider this to be the noun and the pull-down menus to be verbs, and I will make a copy of that particular data. And now I can move the window aside and look for some graph paper. Simply point to the graph paper, selecting the mouse button, and now the application that does graphing will be loaded into the system, and I can simply say, well, I would like that data to be plotted X and Y, so I just simply move down and I simply say paste, and the data is then pasted there. And as you can see that the data the number of digits was actually longer than fit in that particular area, so I simply move the column along the side, move the column heading to the right like you would do.
So a graph appear there.
And then there's a graph, and if I want to see the graph, I can see the graph. And if I'm not interested in my data, I can move it. I can move that over, and
Okay,
you
John,
see a pie chart.
I have to interrupt. I know you said it took you 3 years to figure this out, and I gave you 3 minutes to explain it.
It's okay.
However, coming up in just a minute, we're going to take a look at Vision, another version of integrated software, and that'll be next. Joining us now is Bill Coleman. He's group manager at VisiCorp, involved in the development of Vision, which is VisiCorp's version of integrated software, I take it, Bill. And maybe you can give us a demonstration of Vision.
Yes, we call Vision the applications manager. It's an all-software system in which applications can be installed and the integration is provided. With Vision, you manipulate it with a mouse. There's a global command line. Commands are always available to actually maneuver and utilize the windows, all communications between the windows. I'll give you a demonstration of manipulating the window. You make a selection just by selecting with the mouse. Prompted to select the window you want to open. These happen to be closed windows I've previously opened for this demonstration. I'll open the services window. You notice while something is going on, you'll get an hourglass. Now we've opened a window. This window happens to be all the services available to the user in Vision. I'll manipulate this window just to show you how they can be manipulated. This is open. We can utilize the full screen. There's a lot of times when you're entering text or using your spreadsheet, you're going to want to use the full screen. You can frame it to any size or location just by selecting it, determining the location and size you want it to be. It'll be recomputed and put into a window of that size. All windows have basically three usable components. There's the contents area in which the application actually operates. There's the menu area in which the menu operates as you point to something that's selectable in the universe. And there's something called an option sheet, which you can configure this option, or in this case the services window, Vision itself, to operate the way you'd like to. You may have heard the beeping that's been going on. I'll scroll this up. There's an option down here I can change so I don't have to listen to the beep in my office. Now it'll just flash. If I do something right once, if I do something wrong 3 times. When I'm done with that, I can quit it. Another capability of Vision, as in a lot of integrated applications, is help's always available. Just select help, point at something you want help on, say I don't know what the start command is. It'll open up another window in the center of the screen, unfortunately, over this one, which will describe specifics about that. You can find out more or less information going through. We'll get rid of that window. And I'll open up a graphics window, which has a graphics program running, and I'll open up a spreadsheet window. These are 2 applications I've previously installed in the system. I've opened the window. They have applications running. There are things you can do. You can do all of the normal spreadsheeting and graphics functions, but when using these windows, you now can transfer data from one to another. I'll transfer some data. Basically, select Transfer. Select the window in which you want to transfer from. You select the actual data you want to transfer. Say I want to transfer a column of numbers here. And that's the data I'll transfer. It'll highlight now. And I'll transfer it to this application.
Okay,
now,
Bill, I have to interrupt because we want to get to talking a little bit about this.
Okay.
We're talking about integrated software, and maybe, John, you can talk about this. Lotus 123 is a program we hear a lot about now as an example of that. How would Lotus be different from, for example, the Lisa you showed us or Vision?
Okay, I think it's very simple. Lotus is one application. And basically what they've done is they've implemented spreadsheeting, graphics, and some database intrinsics within one application. It's bounded by that particular application, and its data structures therefore know about the 3 different types of data. There is no integration beyond that, say, to an accounting package or any other piece of software anyone may write. I think with Lisa, and if I'm right, with Vision, these are systems themselves. They are architectures themselves, and they provide a interface to other applications so that you can install additional applications into the environment and therefore cut and paste information from them to other ones.
This brings up a good question. Do you consider Vision and Lisa, are they both really closed systems in the sense that you provide the applications, or do you define how those interfaces are actually set up so that a company X can come in there and write an application that runs, say, under Lisa and uses all those facilities you've already defined?
Yeah,
the same thing for Vision.
Well, they're both open systems. We are both in the marketplace providing a toolkit that allows applications developers to write their applications. And as John mentioned, both of these systems provide a lot more than just the services underneath. They provide the tools and the structures such that a developer can utilize the facilities of the system so that the interface and the usage of the mouse and the usage of menus and all of the facilities are provided and that they're consistent. A user won't have to relearn from one application to another.
That's also true for Lisa.
Yes, I think when Lisa was introduced, it was introduced with 7 applications, a terminal application as well, in terms of taking data off a central database and then moving it into the word processor. And there is a toolkit, and that toolkit is available, and it allows a user to, say, write an accounting package or a legal package, and rather than having to attempt to embed word processing into a legal package, they can use the word processing or one or a number of word processing packages that have been written for Lisa and get the integration through the architecture rather than, trying to build it into an application. The question is how big can an application get before it runs into the boundary conditions of the hardware?
An alternate scheme, I guess, is one that Desk, or the Quarterdeck people have come up with, called Desk, D-E-S-Q. And their idea is basically to put a layer of software over the top of existing applications, such as the word processors that already exist. Do you think that this is sort of a patchwork approach right now, or is it going to go away, or is that an approach that's really going to be successful in the long term?
You want to answer that one?
Well, I think it has its place. It's not a level of integration. What it does is it provides a way that you can view portals to current existing applications. Therefore, there's little or no integration for the
creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and this is Gary Kildall. On today's program, we're going to be talking about integrated software, the new breed of business programs which all work together. And when we mention integrated software, you probably think of Apple's Lisa. Well, in just a few minutes, we're going to be talking to the man behind the Lisa project, John Couch. But first, Gary, there really was integrated software before Lisa, wasn't there?
Well, we're actually talking about two different interrelated topics. One of them is integrated applications, and the other is the use of a visual interface. Integrated applications generally is a term that's applied to business applications that work together, such as a word processing system, a spreadsheet, a graphics drawing package. And they're integrated when they use common data formats and common command formats. The second topic is really the visual interface. The visual interface really uses a new technology of high-resolution graphics to make that program-to-user interface a little more enhanced and animated and a little more fun to deal with. So the Lisa and also the Vision that we'll be seeing today are really descendants of the Xerox Star, which was really then in turn a descendant of the work that was done by Alan Kay and Smalltalk at Xerox PARC.
Okay, before we meet John Couch and Lisa, let's take a background look at the principle of integrating work functions.
Integrating the various branches of an organization to work in unison has never been simple. If each task or department is isolated, making them work together requires clear and accessible channels of communication. At the very least, they all need a common language to clearly assign jobs, coordinate tasks, and make changes as quickly and as directly as possible. In this regard, computer software has a long way to go. Until very recently, the kind of software program...
Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.